Ladies and gentlemen, have a good afternoon and welcome here to the last presentation at the Technical Forum of the Group Exhibit Hydrogen Fuel Cells and Batteries in Hanover 2014. Come in, have a seat, have a drink in the house and enjoy with me our next presentation dealing with the topic Extreme Hybrid Power Sources. And your presentator is Dr. Paolo Fracas, the Chief Executive Officer from Genport Power Solutions. So give him a big hand, please.
Good afternoon. We are talking about a new breakthrough technologies enabling to solve the problem of current technologies to storaging energy. Acid-lead batteries, which are unreliable and very heavy and costly to replace, and generators, which are very noisy and emit dangerous emission, cannot produce electric energy indoor. These two technologies, which are well diffused, are stretching the ability of a new generation of portable electronic as well as small stationary electronic to operate in extreme environments in a most reliable way, and to provide compact energy solution with with low volumes and lightweight. So we approach this problem with a variety of technologies ranging from custom small hybrid lithium batteries to hybrid fuel cells, which will be the subject which I will mainly talk today. Our technology is based on a wide range of patents which are covering the major aspect of our technologies. The company is a spin-off of Politecnico Milano, founded in 2009. We are a mix of academic shareholders, managers coming from the energy sectors and materials, and industrials. We have a wide cooperation with universities in Europe as well as in other countries and industrial entities. We are located in Milan, and we have as well as another location in Cours Purdue Research Park in West Lafayette, which enable us to have a tight cooperation in military program, aerospace program in Indiana States, with thanks to the University of Purdue. We have a collaboration with a US-based company based in Philadelphia, which is providing us a technology for energy storage based alumi-fuel. Now, our expertise comes from long-term activity in PEM fuel cell materials, solid oxide fuel cell material, and characterization of these materials, and move to power electronics, which is enabling us to have a know-how to understanding the on the basic electrochemistry process, and enabling us to define combination technologies and control strategies which are unique to solve problem in off-grid context. Battery fuel cells usually are considered as competitors' technologies. Not true. Battery usually, I would say mainly lithium batteries, are good technology to provide quick and easy powers to device for short term, for a couple of hours, in combination maybe with primary renewable energy source, but are not enough, or you need to spend a lot of money or have a lot of weight and volumes if you need to extend from a few hours to a few days. So you need to extend run times. You need to move from batteries to portable to fuel cells, and then combustion engine, thanks to the properties of the energy density of gasoline, still today is a good solution, maybe for large power system and extended run times. The combination of lithium batteries and fuel cells, which is our expertise, enabling to capture the advantage of both technologies. You can see on the right, on the left side of on the picture. This is a picture made by a Department of Defense in the United States to characterize understanding what's advantage and comparing the two different solutions in terms of missions, time, and requirement of power in terms of weight. The fuel cells itself has some advantage when you need to powering or you have a mission limited on the time, as well as the batteries. But when the mission is lasting more than 70 hours, then the combination batteries and fuel cells is having a lot of advantage. The same is for industrial application, combining a renewable energy source, hybridizing wind and solars with lithium batteries and solid hydrogen. You have the lowest capex per kilowatt hours you can find. We are addressing a market, a multi-billion market, extending from defense to and first responders to telecommunication and off-grid indoor and outdoor agriculture, which is already in place. And we expect an additional demand for such technology in residential applications. Now, that's the typical architecture of our technologies, hybrid technologies, with the brand of different product lines associated with the technologies. We have products which are providing energy in the combination of photovoltaic panels with lithium batteries, which are, again, as I said, satisfying the demand of energy for half a day or extended that until the batteries has enough capacity. But if you need to extend more even in the night when there is no sun, then you need to have an additional storage source, and we considered hydrogen as a valuable solution. So we combine our systems, photovoltaic and lithium, with different storage of solution of storage of hydrogen in a metal hydride, as well as not rechargeable sodium boron based storage of hydrogen. And then finally on the right side you can find the layout of a fuel cell, which still include batteries as a startup or as a peak power. All these technologies are embedded on a different product line which are already available, and I will describe later how they can work. They can operate as a standalone solution or can be operated in a integrated approach. Lithium batteries. Lithium batteries can be utilized as an independent source of energy to extend the run times of your portable device, computer, laptops, mobile phone, or embedded into the final devices, the unmanned systems or medical devices system. So it's really important to consider these elements since the beginning of the design of your device. The lithium batteries, it's a high energy density carrier, but which needs to be properly protected by electronic circuit and managed in order to avoid explosion and extend the lifetime of this device. There are important certification norms you have to consider when you are sizing engineering battery packs to utilizing and also to deliver the system. And this is has an impact in terms of a cost. If you don't consider the beginning of a design of electronic. I make an example, typically company which are designing electronic medical device equipment, they are designing all the electronics and at the end of this design they have a very accurate result in terms of capacity requirement of this portable device, and they left space for the battery in an area which is more suitable. So it's a consequence of a design of electronic. Sometimes happen that this electronics is placed nearby the microprocessor, which is a source of heating, and this causes a problem because can reduce the lifetime of the batteries. So our capability is we usually start to assist our customers since the beginning of the design, try to identify which are the certification, analyzing this certification, provide the best suitable solution in terms of materials, mechanical enclosure, electronic design, and system integration. And we arrive to produce thousands of these units. It's unbelievable area of application of these technologies today, from a robot, a man robot, to powering automotive systems, electrical bicycles, and also as additional auxiliary power unit to also fuel cell in some case. Now, if you can combine these battery packs, if you embed inside a circuit certain features to manage the integration with photovoltaic panels directly, and we usually do that in the electronics. There are already circuit that enabling to recharge directly from solar panel with also an MPPT functionality, which is enabling to capture the optimum power by the solar panels. In combination with partners, we have designed flexible panels, again because we have not a lot of energy in off-grid context. These panels should have an extremely high efficiency, so we try to select the right solar technologies with an appropriate lithium-ion chemistry in order to find out the most lightweight solution, working from minus 30 degrees up to 70 degrees. Typical application also is powering computers of military electronic in the desert, in area where there's a high fluctuation of temperatures. There's been asked also to utilize this type of equipment in an explosive environment. So you have to consider all these aspects when you're designing lithium packs, which is an explosive chemistry which should operate in an explosive environment. Now, sometimes you need just only a few milliwatts of energy for wireless sensor. In the upcoming machine-to-machine new technologies, a multi-billion industry. You just need you cannot need a battery, or you need to extend the lifetime of a battery. So another technology that can be utilized is harvesting energy technologies. It's a combination of power electronics with energy storage, lithium-ion or supercaps, which are enabling to capture highly intermittent primary energy source coming from small solar panel integrated with a piezoelectric or thermal source, and converting into a supercaps. What's advantage? Lifetime. You extend the lifetime of a batteries to the lifetime of a power electronics and supercap, which is usually 5 times more. And safety. If you need to powering a device, a sensor in an explosive environment, it's very dangerous to storage the energy required for the lifetime of a sensor. And with this type of energy, you capture and you storage the energy that is necessary the 1 hours of the day, every day. Moving up to 300-watt systems, talking closely with the defense industry, we have designed this unique fuel cells, which is a CE market product, certified to work in a harsh environment from since -20 degrees up to 45 degrees. It's a 300 watts generators, providing energy to 220 or 110 and 24 AC in the same time. And the application typically are charge battery, using the energy to charge batteries for rescue teams or dismounted soldiers. Usually soldier requires to recharge daily their batteries, and they cannot have on-site some generators, or this is noisy and is releasing thermal signatures. The fuel cell has a great advantage. The system is already demonstrated to work up to 3,000 hours and several thousands of run times. We tested the system with different tactical telecommunication systems as well as medical devices. Is realized in a rugged case with reinforced carbon fibers covers, which enabling the system to be operated in extreme conditions. CE market. The certification of a fuel cell takes a lot of time. Designing a prototype is almost easy. Running for a long time a fuel cell is a little bit more difficult, but the certification is really a relevant job, because you have electrical elements, batteries which are storing energy, hydrogen, running all together in the same environment. So we spent almost 1 year to pass all the CE market, and the product is ready. Providing hydrogen is a key issue in portable fuel cell, so we have designed different solutions. PEM electrolyzer, there is a wide variety in the market. What we made is to ruggedize an electrolyzer already available, in order to have a portable solution that you can utilize on the field. This is a system that can produce from 2 liters up to 3 liters, 2 to 4 liters per minute. And it's the key advantage of this technology is extremely robust, and with a lifetime of more than 1,000 hours, enabling to operate with a highly fluctuation of energy coming also from solar panels. Another advantage of this technology that is providing the hydrogen at the same pressure that you can storage. Same concept for the storage of hydrogen with the rechargeable metal hydrides. We are bringing a canister 1.5 cubic meter up to 3 cubic meter into a rugged case. We embedded thermal management based on Peltier cells, so we can solve completely the problem of charging and discharging such type of metal canister. This type of storage provide up to 10 hours, 3 kilowatt hours of electrical energy to our fuel cells. Combining fuel cells and lithium batteries under a regional project. We have integrated into this rugged case all the entire concept, which is including the PEM fuel cell, the lithium ion batteries, and metal hydride canisters. This system has been found very interesting for small off-grid telecom towers and sailing boat. Sometimes metal hydrides cannot face completely solutions for energy storage because has a good volumetric energy density but poor gravimetric energy density. It means that it's quite heavy. So to solve this problem, we have identified different solutions based on chemical hydrides. We have been probably the first a few years ago to identify, define and control strategies to produce hydrogen on demand directly by sodium borohydrate for a 300 watt fuel cell. So you see here the profile of hydrogen generation that is fully controlled from 0 to 5 liters per minute. Using a portable microreactors. These fuels, named GenFuel, is based on white powders, which is including sodium borohydrate and organic compounds. It's extremely lightweight, extremely safe, and is very clean. The byproduct is utilized in the food industries. Another very interesting alternative as solid hydrogen in which we are focused on is hydrogen on demand by water electrolysis of aluminium. This is a technology where there's been spent much efforts in the last 30 years due to the control of the reaction. We've been able, with the partners in the United States, to find a patent solution which solves this problem, is able to produce hydrogen on demand up to 3 cubic meters per hour. The key advantage is of this solution is the weight and in combination the cost. We have objective to go on the market with a cost below €1 per kilowatt hours of electric energy produced, which is a revolution in off-grid industry. So combining the previous technology which I mentioned, this is an architecture, typical architecture on off-grid context that we usually design and configure with our basic technologies. We utilize sophisticated software to size the systems because every location requires a different combination of technologies and a renewable energy source. But we usually strongly recommend, even for primary energy source, to combine wind and solar energy generation system in order to have a lower fluctuation in primary energy. Energy management systems provide a conversion of the energy and a real-time dynamic control of the entire system. In our philosophy, the lithium batteries provide the dynamic basic requirement of electric energy requested by loads, while the fuel cell provide only the energy requested in a certain time, usually 3 days every 3 months. The reason for that is that due to the low efficiency in conversion of electric energy from an electrolyzer you have an impact in the size of the wind and the solar system, which has an effect in the capex, overall capex cost. So we try to as much as possible to storage and convert the energy through the lithium batteries, and utilize the exceeding energy of renewable systems to storage in the long term hydrogen. In a cost-effective solution that we are working in the medium term is a replacement of electrolysis, water electrolysis with aluminium water-based electrolysis. The reason for that is that in off-grid, again, if you have a problem of installation of large renewable systems or be competitive in terms of cost, you try to but you need hydrogen just only to for 2-3 times a year. You can utilize fuels. So we, as a consequence of our technical economic analysis, we consider this is the most effective solution to approach the off-grid contest. The basic module for the lithium energy storage is the GENIOL 6000 watt-hours, is our BESS, battery energy storage system, mounted in a standard 19-inch rack. It's the key advantage of this system is the modular architecture. So each 6000 watt-hour system is based in sub-modules with their own battery management system technologies, and this helps to improve the reliability, reduce the cost of maintenance, and manage the system at the level of single cells of the batteries. The system can work independently without a fuel cells with a renewable energy system. This is the majority of application where you do not have to guarantee the 24 hours, 7 days a week, constantly electric energy. So if sometimes during the years you don't have sun, you don't have wind, the system, and you have a smart load, you can load shedding such type of loads. That's the most effective solution. And the such type of battery storage in the near future can be utilized as a distributed energy storage in a smart grid, integrated with the renewable energy source in isolated grid with so-called swarm inverter technology that we are setting up with the partners. Now, fuel cells and lithium batteries should be in off-grid should be managed with sophisticated algorithms if you want to have dispatched properly and have your own energy when you need it. So we have our control system are based on a two-level optimization control engine, which is a result of research of the last couple of years. And this control system are based on first level on-site, which is digital analogic control to manage the batteries and the fuel cells and the energy storage. And we have in our server and running the engine, which is controlling instantaneously all our systems, providing every quarter of hour the basic control to the low level. This type of control provides also the real-time diagnostic monitoring, which is able to predict the maintenance available on site. That's all. Thank you for your attention.
Thank you. Mr. Fracas, for this informative, interesting presentation. So are you here any questions right now? If not, so we are just in time, en punct. If not, I think you are here at the group exhibit the
Yes.
whole day. So don't hesitate to contact Mr. Fracas here. It's a booth number E61/2. And thank you again. So we are at the end of our program from 2014 from the Technical Forum here. Thank you for your attention. Thank you for staying and hope to see you again next year. Goodbye.